Welcome back to another video. We're still talking about linear equations and their applications to simple geometric problems. And in this case, we will continue to look at angle problems, specifically for polygons. So in a previous video, or two videos really, we looked at angle problems for triangles, but in this case now we would like to look at any type of polygon, and to do that we will remind ourselves of the rule for angles and polygons. But before that, I just wanted to remind you that down in the description there are links to the previous videos that talk about linear equations and how to solve them. And of course the examples with the triangles, they're all listed in the description below. If you're new to the channel, please subscribe. And let's get started. So when we look at different types of polygons, triangles, squares, all the different types of polygons, we know that there are rules about their angles. So there are rules about the sum of the angles of a polygon, and specifically the rule is that the sum, so we look at the sum of all angles. The sum of all angles should be equal to 180 degrees times the number of sides. So n is the number of sides minus 2. We'll call that sum capital S. So for a triangle where n equals 3, right? We have 1, 2, 3 sides. We have the sum of all angles equals 180 degrees times 3 minus 2, which is equal to 1. So S equals 180 degrees. And for a square, for instance, where we have 4 sides, right? 1, 2, 3, 4 sides, S equals 180 degrees times 4 minus 2, which is just 180 times 2, which is 360. And that is true, of course, also for rectangles that have 4 sides. And so on. If we have an 8-side polygon, so for an 8-side polygon, S will be equal to 180 degrees times 8 minus 2, which is 180 times 6, and you can do the math yourself. So this is the general formula for the sum of all angles in a polygon, and it could be a polygon of any side. So let's look at one specific problem. Let's look at a 6-side polygon. Draw a 6-side polygon. As you can see here, it has 6 sides, and therefore it also has 6 angles. 1, 2, 3, 4, 5, and 6, and we'll make this kind of a simple problem. Let's say that that 2 of our angles have a value x. Okay, this one and this one, it's a symmetric 6-side polygon, and the other angles have a value of 150 degrees each. So all of these angles now will have the value of 150 degrees each, and we have to figure out what x is. Okay, so we have 2 x's here. We have 2 angles with the measure of x and 4 angles with the measure of 150, and we can write out our formula. So write the sum of all angles equals, we have 6 sides, so we have 180 degrees times 6 minus 2. And we can simplify this to 4, right? 6 minus 2 is 4, so the sum of all angles equals 180 degrees times 4. So now let's write out our linear equation, taking in mind this formula. So what is the sum of all angles? We have x, right, for angle number 1, plus 150, plus 150, plus x, plus 150, plus 150, equals 180 degrees times 4, where I've gone basically clockwise from the x from this x around the polygon. Now the first step we always do is combine like terms, right? So we have variable terms and we have constant terms. Let's put our units on these angles here. So the variable terms we have two x's here, and since they're the same x, we don't know what it is yet, we can write that as 2 times x, right? So I've accounted for the variable terms, and then we have 4 of these 150s. So let's write that as 4 times 150 degrees, and that should be equal to 180 degrees times 4. Now, note that I've left it with a multiplier here of 4, and that's on purpose to show you how sometimes if we leave things in a symbolic form rather than calculating the product, it can simplify our work later on. So let's continue. So what do we have here? We have 2x plus 4 times 150 equals 180 times 4. Let's do the next thing, which will be to combine the constant terms. So we will combine now the constant terms, and we do that by using the subtraction property of equations. Okay, so what we're going to do is we're going to subtract minus 4 times 150. So we won't calculate what that equals, we'll just subtract it. So we have 2 times x plus 4 times 150, I'm just copying it down, equals 180 times 4. And now I'm going to subtract 4 times 150 from both sides. Okay, so now on the left, we have 2 times x, that comes down here, but we have plus 4 times 150 minus 4 times 150, and so we're adding and subtracting the same term, so that equals 0, equals, and now I'm going to change the order of this multiplication. I'll write it as 4 times 180 minus 4 times 150. Okay, now it looks like we have the same coefficient here, right? On the right, we have twice this coefficient 4. So let's make use of that using the distributive property. So we can write 4 times, and we'll open a parentheses. I'll bring down this 180, and I'll bring down from here this 150, and I'll keep the 4 outside the parentheses so that it is multiplying both terms. But now I can calculate what's inside these parentheses before I do the multiplication. And 180 minus 150 is just 30. So we have 2 times x equals 4 times 30 degrees. Now our next step, again, before we actually multiply, let's use the division property. So when we use the division property, we're doing that in order to simplify the term here on the left that has a coefficient. So let's divide by 2. So we have 2 times x divided by 2 equals 4 times 30 divided by 2. Okay, let's do some simplification. The 2 and the 2 here. So 2 halves just cancel, right? So we have x equals. And now let's divide the 4 by 2 because that's simple. And we get 2 times 30. Again, since we're dividing a product, we don't have to divide both items. We're dividing a product, so we divide one of them. And we have x equals 2 times 30, which is just 60. So we have x equals 60. And that is our result. We can now check by adding up right? We can check by substituting and adding up all our angles. And so we have 2x's plus 4 times 150, which equals 2 times 30, right? I mean 2 times 60, apology, plus 4 times 150, and that equals 120 plus, this is 600, which equals 720. So now let's check that 720 equals 180 times n minus 2, where n, remember the number of sides was 6, so we have 720 degrees equals, let's put a question mark there because we still haven't finished checking it, n minus 2, 6 minus 2 is 4. And let's do that off on the side. 4 times 180, so we have a 0 here. 4 times 8 is 32, so we write 3 and carry through. We write 2 and carry 3. We have 4 times 1 is 4. We add the 3, so it's 720. So indeed, 720 equals 720. And so our result is correct. Let's take a look at one more problem. In this problem, we won't know a priori what type of polygon we have. So we have an unknown polygon, okay? And we'll say that what we do know about it is we know the sum of all the angles. So we know that the sum of the angles equals let's say 900 degrees, okay? So this is what we know. And using that, the question is, how many sides does the polygon have? Okay, so let's see if we can write up this problem as a linear equation. Now, what we do know is that in general, the sum of all the angles equals 180 degrees times n minus 2. But in this case, we don't know n. This is not known, but we do know s. We do know the sum of our angles, and it is 900. So let's write that. So we have 900 equals 180 times n minus 2. Now in this equation here, 900 equals 180 minus times n minus 2. This is an equation, right? But we have a variable here that is n. So we don't have x this time. Our variable is n, and it happens to be the number of sides. Okay, now we can use this equation to solve for n, just like any other linear equation. This time, n is not a part of the angles, but has to do with the number of sides. So let's go ahead and do what we know how to do. So looking at this equation, we have mixed terms on the right? We have variable terms, and we also have constant terms. So one thing we can do is, using the distributive property, we can open the parentheses. That's one way of solving it. The other thing we can do, okay, I'll write that as 1, and maybe we'll use both ways, and that way we'll review the different things we know how to do with linear equations. We have, on the one hand, the opportunity to open the parentheses and move our components around and combine like terms. The other thing we can do is start with, so this is the distributive property, and we can start with the division property by moving the coefficient 180 to the other side out of the way and simplifying our equation. So let's do both things and see what happens. So let's write out the equation again down here. So we have 900 equals 180 times n minus 2. Okay, so let's look first at using distributive property first. And I'll make that first. So first, using distributive property, in that case we have 900 degrees equals, we open the parentheses, 180 times n plus 180 times minus 2. Okay, negative 2. And that is because we have the negative 2 here. Let's simplify this. 900 equals 180 times n. And instead of writing 180 times minus 2, let's just write minus, and the product is equal to 360. Now let's use the addition property. So we'll add 360 to both sides of this equation. And we get 0, 6, 12. So that's 1,260 equals 180 times n, and these two terms cancel. Next, we can use the division property by dividing both sides by 180, and on the right-hand side, we're left with just n, because these two terms cancel, right? The 180 divided by 180, and then we have to divide 1260 by 180, and that just equals 7. You can go through the division yourself. And so we get 7, n equals 7. So that's one way of doing it. Another way of doing it is by initially using the division property. So we will first divide by 180, and then we'll see what we can do to simplify. So when we do that, we have 900 equals 180 times n minus 2, and we will divide both sides by 180 right away. So when we do that, again, the 180s here cancel because they're the same in the denominator and numerator. And 900 divided by 180 is just equal to 5. So we have 5 equals n minus 2. And then we can use the addition property by adding 2. Right? It's the inverse operation to minus 2. We'll add 2 to both sides, and we get 7 equals n. So in both ways, we get the same result, but I think that this way, this first division, using the division, was the quicker method. So it's a good idea to take a good look at the equation and decide, based on its structure, what would be our first step. Now, looking at this result, we can check it. As always, we can check by substitution. But we also should look at the result and see if it makes sense. And in this case here is the number of sides, right? Number of sides. And the number of sides has to be a positive whole number. We can't get 4½ sides, and we can't have -3 sides. So the fact that we got a whole positive number is a good sign, and it's always important when we have a problem, especially a word problem or a geometric problem, to check that our result makes sense, that we don't get negative angles, that we don't get fractional sides or negative sides, negative volumes, and so on. So this brings to an end this video. We will follow up with videos now that have to do with perimeters of shapes and areas and even volumes in the next few videos, just to practice our linear equation solving skills, and also to remind ourselves of the various formulas that govern various shapes and their areas, volumes, and perimeters. So thanks again for joining me. Look at the, if you had any trouble with this video, take a look at the earlier videos that are linked to in the description below. As always, if you're new, please subscribe, and any comments are welcome. See you next time.